Hey, Mr. Zeki! This is my awesome full-color periodic table made from Lego. I was going to show it to you in person before. Well, you know. Anyway, I thought I'd show it to you in this video instead. Today, I'm going to tell you about the periodic table of elements and the properties of each group. The periodic table of elements was designed by a Russian chemist named Dmitry Mendeleev in the late 1800s. He developed the table to quickly display and organize all the known elements, and even managed to predict elements that were known at the time. This table has 18 columns, called groups, and 7 rows, called periods. The periodic table is divided into 12 parts or families, grouped together because they share similar chemical properties. They are the alkali metals, the alkaline earth metals, the transition metals, the lanthanides, the actinides, the basic or post-transition metals, the metalloids, the nonmetals, the halogens, and the noble gases. Some of these families contain elements from a single group, while other families comprise elements from more than one group. On the far left, we have the alkali metals. This group of elements is made up of soft, shiny, and extremely reactive metals. In fact, they're so reactive, some of them even spontaneously combust when exposed to room temperature air or water. The elements of the alkali metals are grouped together because they all have one electron in their outer, or valence shell. As you go further down the column, the elements get more and more unstable in their elemental form. This is because the atoms grow larger from additional protons, neutrons, and electrons as you go down a column. For each new period, the additional electrons appear in new electron shells that are farther from the nucleus, causing the electrons to be lost more easily. This means that the lower elements will become much more violently reactive. Alkaline earth metals are the next column in the periodic table. These elements form group 2, and they have 2 valence electrons. Due to those 2 valence electrons, alkaline earth metals are also extremely reactive. They desperately want to get rid of the 2 valence electrons. Initially, when the properties of alkaline metals were discovered, chemists believed that they were unreactive. This was actually because the elements of group 2 were always bonded to oxygen when found in the environment, which stabilized them. Electrons have a negative charge, and when atoms give them away, those atoms become a cation, meaning an ion with a positive charge. The alkaline earth metals have 2 valence electrons, so they become +2 cations once they lose their electrons. Similarly, the alkali metals form +1 cations when they give their sole valence electron away. The next section is the transition metals. These elements are typically lustrous, silvery, durable, and good conductors of electricity. The main difference between transition metals and the group 1 and 2 metals is that while the alkali and alkaline earth metals are soft, the transition metals are generally hard metals. They also lose their electrons and gain electrons from other atoms quite easily. The transition elements will exist as either neutral elements or stable ions, and sometimes lose or gain many different numbers of electrons in various ionic states. Interestingly, transition metals also have some paramagnetic properties. This means that metals that are generally not magnetic can become weakly attractive for a short period of time after an external magnetic field is applied. Lanthanides are our next family of elements. They are situated between the 2nd and 4th elements in the 6th period, and these elements are a fascinating bunch. The lanthanides are often called rare earth elements, REE, due to the difficulty in extracting them. Rare earth elements have a lot of industrial uses, the most well-known being rare earth magnets. Rare earth magnets are made with an alloy of neodymium or samarium combined with iron, nickel, or cobalt, and they are capable of lifting thousands of times their own weight. These elements form positive ions when in solution. The family directly below the lanthanides are the actinides. They can only be produced in a nuclear reactor, except uranium and thorium, which are naturally occurring in trace amounts. They are also very unstable, and many of these elements last for tiny amounts of time due to radioactive decay. Basic metals, also known as poor metals or post-transition metals, are a family of elements on the periodic table to the right of the transition elements. They are soft metals with some nonmetal characteristics, and 2 of these are well known for being toxic: thallium and lead. The basic metals are generally softer and more malleable than the transition metals and have more electronegativity. That is, the ability an atom has to attract other electrons. Next, we have the metalloids. This family is made up of 7 elements, and they have a mixture of both nonmetal and metal characteristics. Some of these elements are semiconductors, meaning that they can be made to carry an electrical current only under specific circumstances. This property makes a few of the metalloids, such as silicon, extremely useful in the circuits of computers and other electronics. These metalloid elements stretch across 4 columns in a staircase pattern. On the right side of the periodic table are the nonmetals. Nonmetals are the opposites of the metals. They have relatively low boiling points, are poor conductors of heat and electricity, and don't like to lose their electrons. The most familiar elements from the section, such as carbon, nitrogen, and oxygen, are essential to life. Carbon, for example, is vital because carbon is the basic building block of all living organisms. Organic molecules, which are based on carbon, are involved in all aspects of life. Most nonmetals are solids at room temperature. However, a few are gases. When nonmetal atoms bond with other nonmetal atoms, they share their electrons so they can both fill up their valence shells. This form of bonding creates what is known as a covalent bond. The halogens are the next family of elements on the periodic table. Halogen literally means salt formers, and they're called this because they have a tendency to bond with alkaline metals and form ionic salts. Because the halogens have 7 electrons in their valence shell, they are more inclined to take electrons from other atoms rather than lose their own electrons. The halogens cover all 3 states of matter, which is pretty rare for a single group. Fluorine and chlorine are gases, bromine is liquid, and iodine and astatine are solids at room temperature. The final family of the periodic table is the noble gases. These gases are colorless, odorless, and inert. Most of the noble gases have 8 valence electrons, which means that they don't tend to gain or lose electrons easily. The only exception to the 8 valence electrons rule is helium, which has a full set with just 2 electrons. Because the noble gases have a complete set of valence electrons, they don't need to bond or attach to other elements to achieve stability. In conclusion, I hope I've demonstrated that I've extended my learning for the elements and their properties unit. Thank you for watching. Bye!